So now we are starting our lecture. So in the last time we were discussing the dual nature of the photon. So as we know that the photon has a dual nature. So here we are discussing dual nature of photon. So in this dual nature we have discussed one of the nature of photon is as a particle nature. So in the particle nature, we have seen that there are two main experiments were performed. The number one is the photoelectric effect, and number two is the Compton effect. So these are the two basic applications, which is the photoelectric effect and Compton effect. These two basic equations indicate the photon as a particle. So now in the previous lectures, we have discussed the effect of the photoelectric effect. It means when the ultraviolet light falls on the surface of a metal, as a resultant, the electrons are emitted from the surface, and the phenomena is known as photoelectric effect. So now here in this lecture, we will focus on the Compton effect. Okay, what is the Compton effect? So here in this case, Compton effect, this is the electron at rest, and it is a photon whose wavelength is lambda, whose velocity is c, and whose frequency is f. When it strikes with the electron, this is the electron at rest. So as a resultant, this photon is scattered at a certain angle and transfers energy to the electron. As a resultant, the electron is scattered at a certain angle. This is the original path of the photon. So we may say that the photon is scattered at an angle phi and electron is scattered at an angle theta. So now we have to look at how much energy this photon transfers to the electron when the electron is scattered at a certain angle. So we have to look at. So here in this case, we have seen that the energy transformation to the electron by the photon is totally depends upon the angle of scattering of the photon. So if we say that here the wavelength is lambda, which is the wavelength of the original incoming photon, or we may say that this is the X-ray photon, high energy photon, and this is the lambda dash, which is the wavelength of the scattered photon. So now from the law of conservation of energy and from the law of conservation of momentum, we can easily find out how much energy electron transfer, how much energy the photon transfers to the electron. So as a resultant, we may say that the energy of this E is equal to hc over lambda. This is the energy of the incoming photon, and this E dash is the energy of the scattered photon, which is equal to hc over lambda dash, because h is constant, which is the Planck's constant, c is the speed of light, and lambda dash is the wavelength of the scattered photon. The electron initially, which was at rest, so its energy E is equal to m naught c square, and which we call it as a rest mass energy, because this is the particle. When the particle is at rest, its energy never be zero. Its energy is known as the rest mass energy. This is known as the rest mass energy. And when the photon transfers the energy to the electron, as a resultant, E is equal to mc square. And this energy is known as the relativistic energy. This m naught is known as the rest mass of electron. According to Einstein's equation, mc square is known as the rest mass energy. Here mc square, this is known as the relativistic energy. So these are the energies. This is the energy before scattering and this is the energy after scattering. This is the energy of the electron before scattering and this is the energy of the electron after scattering. Similarly, so we have to look at from the law of conservation of energy here. From the law of conservation of energy, energy before scattering must be equal to the energy after scattering. So here, energy before scattering is equal to what we say that the before energy is equal to the initial energy of the photon, which is equal to hc over lambda, plus rest mass energy of photon, which is equal to m naught c square, is equal to after energy, which is equal to hc over lambda dash plus mc square. So this is the energy of the electron before scattering, which were initially at rest. So therefore we call this energy is the rest mass energy. And this is the energy which we call it as a relativistic energy. So now this mc square can be rewrite as this mc square is equal to the mc square is equal to m naught c square divided by 1 minus v square over c square, and this is known as a Lorentz factor. This v is the velocity of the electron and c is the speed of light. So the relativistic energy is equal to the rest mass energy divided by square root of 1 minus v square over c square, and we call it as a Lorentz formula, or this is the formula for the conversion of the energy into the relativistic energy. So here this hc square, hc over lambda, this can be bring into this side, which is equal to hc over lambda dash is equal to the, this is m naught c square, this plus minus plus this can be minus m naught c square over 1 minus v square over c square. This can be rewritten as m naught c square into 1 upon square root 1 minus v square over c square minus 1. So this is equal to hc is common, 1 over lambda minus 1 over lambda dash. So this is the equation which we say that this is equation number 2, and this we call equation number 1. This is the relation which we have obtained from the law of conservation of energy. So now we have to look at the law of conservation of momentum. So you know that the momentum is a vector quantity. So here the momentum of the photon is equal to P is equal to H over lambda. This is the initial momentum, which is the momentum of the photon, which is equal to H upon lambda. And the momentum after scattering is P dash, which is equal to H upon lambda dash. So the momentum before scattering, which is equal to H upon lambda dash, and the momentum after scattering H over lambda dash. and the momentum of electron. So now the electron has an initial momentum is 0 because electron is at rest. So the final momentum, which is equal to P, is equal to m into v, which is the momentum of electron. M is the mass of electron and v is the velocity of electron. So now here, this momentum is a vector quantity. This momentum is a vector quantity because energy is a scalar quantity and the momentum is a vector quantity. So now from the law of conservation of momentum, we will see that one is this, the photon is scattered at an angle phi and electron is scattered at an angle theta. So therefore this vector will be resolved into two components. One is the x component and other is the y component. So here this is the moment, this is the photon and it has two components. One is this and other is this. This component is known as a px and this component is known as py. Similarly, this is the electron. Electron has again this component which is the component along x-axis and this component which is the component along y-axis. So it means now from the law of conservation of momentum, we have two equations. One is the momentum along x-axis and other is the momentum along y-axis. So we have to look at, I am rewriting here. The law of conservation of momentum so here momentum P, number one we are discussing along x-axis. So this is equal to momentum of photon along x-axis plus momentum of electron along x-axis is equal to, this is the initial. Here P dash is the momentum of photon along x-axis plus P of electron along x-axis. So here Px is equal to h over lambda cos of angle theta, cos of angle phi, because Px is equal to P cos phi. This is the angle phi. So therefore Px is equal to P cos phi. And momentum of electron, which is initially at rest, so therefore the momentum of electron is equal to 0. So here the momentum of photon after scattering is equal to h over lambda dash. So here it is initially along this, here this is equal to cos of angle phi, because initially it is along x-axis and angle is 0 and cos 0 is 1, so therefore this becomes h upon lambda. Clear? So because initial path is along x-axis, angle is 0 and cos 0 is 1. Here angle is phi after scattering, so which is equal to h upon lambda phi plus the relativistic momentum is equal to mv divided by 1 minus v square over c square. And this is known as the Lorenz factor. So this momentum along x-axis is equal to cos of angle theta, because this angle is theta. So therefore it is a cos of angle theta, because this is the momentum of electron along x-axis. So therefore cos theta factor is multiplied over there. This mv is the momentum and this factor 1 upon square root of 1 minus v square over c square is known as the Lorentz factor. This is multiplied due to the relativistic motion. So now we have this equation. This is, let's say, equation number 3. So now we have equation number 2, equation number 3, and now the momentum along y-axis here taken is momentum along y एक्सिस। अब y एक्सिस में अगर आप ये देखें कि इनिशियल मोमेंटम तो फोटोन का which is along x axis है। Initially photon is moving along x axis, so therefore its momentum along y axis is 0. So the photon is moving along x axis, so therefore its momentum along y axis is 0. So therefore the momentum along y-axis plus momentum of electron along y-axis is equal to momentum of electron along y-axis is equal to momentum of electron along y-axis. This is the momentum of photon along y-axis. This is the momentum of electron along y-axis before interaction. And this is the momentum of photon along y-axis. This is the momentum of electron along y-axis after interaction. So here before interaction, the photon is along x-axis, therefore this is 0. Electron is at rest, therefore it is again 0. Here momentum of photon along y-axis is equal to h upon lambda dash. This is along y-axis, so therefore sine of angle phi, because the photon is scattered at an angle phi. Similarly, plus momentum of electron, which is equal to mv divided by relativistic factor 1 minus v square over c square. Here we have multiplied cos theta because it was along x-axis. So now we are discussing along y-axis. So y-axis it is equal to sine of angle theta. This is along the positive y-axis and this is along the negative y-axis. So therefore this plus becomes a minus sign here, because the vector is in the downward direction, and you know that if we say this is the positive x-axis, this is the negative x-axis. This is the positive y-axis and this is the negative y-axis. So therefore this negative sign indicates that the electron's vertical momentum is in the downward direction. So therefore this negative sign shows such thing. So let's say this is equation number 4. So now we have three important equations. One is equation number 2, which is coming out from the law of conservation of energy. And the second equation is the conservation of the energy along x-axis, which is the momentum conservation. And the fourth one is the momentum conservation along the y-axis. So now from the combination of equation 3, 2, 3, and 4, we will get the resultant, which is equal to the from the combination of equation 2, 3, and 4. We get the final result of change in momentum, change in wavelength. We get delta lambda, the change in wavelength, is equal to h upon m naught c into 1 minus cos of angle phi. This is the final result, which is coming out from the equation number 2, 3, and 4. And this, how it comes out from this is already solved in a problem. I will give you an assignment. Okay? So here, this delta lambda is equal to h upon m naught c 1 minus cos of angle phi. So here, this indicates that the change in wavelength of the photon, it means in the first place, we have seen that the change in wavelength is actually the energy transformation to the electron. It means the change in wavelength depends upon the angle of scattering of the photon. So here, this resultant indicates that the change in wavelength of the photon is totally depends upon the angle of scattering of the photons. Here, The change in wavelength, this indicates that the change in wavelength, change in wavelength of the photon is depending on the angle of scattering of electron. Depending on the angle of scattering of photon. So here, if phi is equal to 0 degree, अगर phi 0 degree है, phi is equal to 0 degree, इसका मतलब क्या है कि electron is moving unscattered. It means the energy transformation is 0. Phi 0 gives you cos of 0, which is equal to 1. 1 minus 1 gives you 0. So here, phi 0 gives you delta lambda is equal to 0. So what does it mean? It means the energy transformation is 0, so the change in wavelength is 0. Because the energy of the incoming photon is same as the energy of the outgoing photon. So it means there is no any scattering. So here, if phi is equal to, let's say, 180 degree. If phi is 180 degree, it means the photon is striking with the electron, and as a resultant, the photon return back. It means the angle is 180 degree. This and returning back angle is 180 degree. So phi is equal to 180 degree. So here cos 180 degree is equal to minus 1, minus is equal to plus 1. So 1 plus 1 gives you 2. So here cos 180 degree is equal to minus 1. So as a resultant, delta lambda is equal to, this becomes 2. So this is equal to 2h upon m naught c. So the energy transformation is maximum. Energy transformation is maximum when the angle of scattering is 180 degree. So now in your book, in your course, there are different angle of scattering. Here, for example, let's say if we say that there is a peak, इसको मैं remove कर देता हूँ. This is the so here if we say that this is the intensity versus wavelength. This is the wavelength in this direction and intensity is in this direction. So we say that this is the peak of the intensity at a certain wavelength. This is the wavelength lambda when phi is equal to 0 degree. There is no scattering. So now here, when here let's say this is one peak and this is the other peak here. This peak indicates the lambda dash and this is the lambda and this gives you the change in wavelength. Let's say this is the experimental curve y phi is equal to, let's say, 45 degrees. So here again the change in wavelength gives this is the wavelength original. This is the one peak. Clear? And the other peak is much higher than this. This is the lambda dash and this is the lambda, this is the delta lambda. And let's say this is at an angle of 135 degrees and etc. So this is the how the wavelength is changed. So this is what about the photoelectric effect. Any question please?